Welcome to this fast class where I'll provide you with an introduction to artificial intelligence for accounting and auditing. So I have four main learning objectives for this class. The first learning objective is that you will be able to clearly define what artificial intelligence is. And how I'll be able to help you achieve this goal is by giving you very clear examples of what artificial intelligence is. My second learning objective is that you'll be able to describe the properties, benefits, and challenges of using AI. My third learning objective for this class is that you'll be able to differentiate the different types of artificial intelligence technologies. And then my fourth learning objective is that you'll be able to clearly define the different levels of AI. So these are my four main learning objectives throughout this class. So to achieve the first learning objective, I'm going to answer this question: what is artificial intelligence? So if you go to the Merriam-Webster dictionary, you'll find that it defines artificial intelligence as the capability of a machine to imitate intelligent human behavior. Another definition that I really like to use is that artificial intelligence is a technology that can mimic the cognitive capabilities of humans. And when I say cognitive capabilities, I'm talking about the ability to see, to speak, to write, to walk, to process information. These are things that we do as human beings, sometimes even without being aware that we are doing this through mental processes. And so artificial intelligence is this technology that is really trying to mimic our capabilities. So I mentioned that the definition of AI is its ability to mimic our human cognitive skills. So think about yourself as a human being. You have the capability to see, right? And AI is trying to mimic that capability to see using a technology called machine vision. So machine vision is very popular nowadays, especially if you think about self-driving cars. If you've heard about the initiatives such as Uber to create cars that can drive and navigate themselves without human help. So these self-driving cars have machine vision. And so they're able to see the road, they're able to see stop signs, they're able to see pedestrians crossing the road, and they're able to stop or move based off the information it collects by observing the environment. So that is machine vision, a technology that is trying to mimic our ability to see. There is also our ability to hear. And if you think about Alexa and Siri, these are all apps that we're using more often now that exhibit artificial intelligence, because these technologies are able to hear what humans are saying, they're able to process our human speech, and they're able to respond back to us in natural language, right? So think about you asking Alexa, what's the weather today? And what Alexa will do is process the words you have said, and then it will convert the words you have said into instructions that will help it to do a Google search, perhaps, and retrieve information from the internet and proceed to just provide that information to you in natural language. So these are all different AI techniques that are very popular nowadays and enable AI to have this ability to mimic our cognitive skills. So this is in a high level, different AI techniques that I will capture in subsequent slides, and then I will talk about in more depth in later classes. And these are just a few of the AI techniques. We have a couple more that I do not capture in this slide. And so before I go far, there's a question I always get. People like to ask, what is the difference between artificial intelligence and other software, such as Excel? So one thing that is common in other regular software, like Excel, is that they are rule-based, right? A human being developed those systems by coding rules in those systems. And those systems generally can process very standard data. For example, if you think about Excel, it can only process numbers. But artificial intelligence is another software that can learn on its own. It doesn't have to have programmed rules. And I'll talk about later how AI learns. And so this self-learning capability is a unique feature of artificial intelligence that differentiates it from other regular software, such as Excel. Another thing is that artificial intelligence is able to process unstructured data. And when I talk about unstructured data, I talk about this means data that doesn't have a specific format. Like, for example, in Excel, you'll see in Excel, there are always rows and columns, right? But unstructured data doesn't have a format. For example, images, voice, text. This is data that varies in size, length, dimensions, right? And AI has this capability to process such data that other rule-based software may not have. So these are just some of those unique features of artificial intelligence that enable it to perform just like a human being, and in some instances, even better than human beings. So artificial intelligence is not a new technology. In fact, there's a gentleman called Alan Turing who in the 1950s was already thinking about artificial intelligence. And he was really struggling with this question: how can you tell whether a machine is truly artificial intelligence? And so he came up with this Turing test. And this Turing test goes like this. If you have a human being, and this human being is interacting with a machine, yet the human being thinks that they're actually interacting with a human being or feels like they're interacting with a human being, then that machine is truly artificial intelligence. So, for example, you asking Alexa, what is the weather today? And Alexa responding to you today, it's going to rain. Then you can say Alexa is truly artificial intelligence because your interactions are voice based. You're asking Alexa questions, she's responding back to you in natural language, just like a human being would do. Then, indeed, that is artificial intelligence. So I mentioned that artificial intelligence is not a new technology, that even in the early 1950s and 60s, people were already struggling with what artificial intelligence is and how they can develop it. And so the main goal early on was that they were hoping to be able to develop a super AI, a supercomputer. And this would be a machine that would be smarter than human beings. But they haven't achieved that goal yet. In fact, in the 1980s, there was a slow realization that building a machine that can behave exactly like a human being would take a lot of effort. And to date, 60 years later, we still haven't achieved this super AI. So the type of artificial intelligence that we have right now is narrow AI. This narrow AI is technology that is good at one thing, one dedicated specific task, right? Or more, a few more, but not too many, right? So this narrow AI is used in specific domains and cannot work in every other domain. So think about you as a human being, right? You can wake up in the morning, you're your own cook, you can cook your breakfast. And then after that, you will clean your house. You can be your own cleaner. Then you can be your own driver. After that, take yourself to school. You can be your own interpreter. You can listen to a different language and interpret what that language is into your local language. You can do so many things for yourself. But an AI cannot do all those things. We have specific AI for specific things. So think about Alexa. Alexa is very good at, for example, maybe interpreting what you're saying, being able to search the internet, find useful information for you. But Alexa cannot clean your house, right? So AI is very specific right now. They're usually built to achieve specific goals. And there aren't too many artificial intelligences that can do multiple things. Most AI that we have right now are built to do one specific thing. And so that's why we can always say right now that we are still very superior to machines because we can do multiple things in diverse ways. But AI generally for now is very narrow and can only handle specific things. So in the previous video, I talked about what the definition of artificial intelligence is. And artificial intelligence, as I mentioned, is a technology that mimics the human cognitive capabilities. So now that we talked about some of the examples in real life of artificial intelligence, I want us to just think about what the properties of artificial intelligence is and what the benefits and challenges are of implementing artificial intelligence. So this video addresses our second learning objective. So before we talk about the properties of artificial intelligence systems, it's important for us to first know how AI works. How does AI learn? How does AI perform its tasks? Because AI is trying to mimic the human cognitive skills, AI learns just like humans, right? We as humans, we learn by observing our environment, by reading books, by looking at different data. And AI does the same, right? It analyzes data and it's able to identify patterns from that data. And those patterns or models assist AI to make decisions. So most of the AI we have is data-driven, right? Think about the self-driving cars I talked about in the previous video. These are cars that are able to navigate on the road. They're able to see signs on the road, and they're able to see, for example, the stop sign. And that stop sign gives it the information that the car needs to stop. So how does AI know that this is a stop sign, right? Or this is a red light and not a green light? It's through data, right? So before the artificial intelligence system is sent into the real world, before the self-driving cars are sent into the real world, they go through data training. And this data training basically is the process of feeding the artificial intelligence system a lot of data, and this data enables it to identify patterns or characteristics of different objects. So for example, the self-driving car will have to be trained on different road signs. And based on that training data, the algorithm or the artificial intelligence system is able to later on in the real world be able to observe and identify different objects based off that training phase that it received during the development stage. Additionally, as I mentioned in the previous video, artificial intelligence systems are able to learn. They're able to observe the real world and learn even during their use. And so therefore they continue to evolve and learn from the data, even in the environments in which they're exposed to. So like the self-driving car, the more it navigates the road, the more it will be able to identify more objects and determine which objects move. For example, it can determine that other cars are moving, and it can determine by observation that trees don't move, for example. And so these are just things that an artificial intelligence system can be developed to learn as it goes along in its particular functioning. So the main takeaway here is that algorithms or artificial intelligence systems learn from data. And once they learn from the data, they develop algorithms or what we call models. And these models or algorithms are used to perform other decisions, right? That the algorithm or the AI is supposed to perform. So for example, the self-driving car with time will develop models that will help it to know when to stop the car when it sees a red sign and when to go when it sees a green sign. So those are the models or algorithms it will develop as it continues to be used in the real world. So this is just a high-level overview of how AI works. AI is data-driven, and AI, after learning from data, develops algorithms or models. And then once algorithms and models are developed, as AI is continuously used within the real world, it continues to learn and it continues to generate or be exposed to new data, and then it continues to evolve. So this is a continuous cycle. So the main takeaway from this slide is that AI is not a one-off development activity like other rule-based software like Excel, right? Microsoft developed Excel once and commissioned it, and now they just do minor updates, but generally Excel was developed once, right? Within the laboratory. But artificial intelligence systems continue to evolve as they're exposed to more and more data. And I'll talk more about this development process, and in advanced classes, we're going to actually develop some algorithms here using data, and you'll be able to see how these algorithms can evolve with time. So now that we are familiar with this cycle of how artificial intelligence systems learn from data and then develop algorithms or models. And then once these algorithms are developed, these algorithms are used in the real world by the AI, and then new data is generated, and then the cycle goes on and on. So now that we know that one of the main properties of artificial intelligence is it's data driven and that also it learns from its environment, let's think about the benefits and the challenges of artificial intelligence. So the fact that AI is data driven, right, is because computers have this great capability nowadays to analyze large data and do it much faster than a human being can do. And so because of this, it's very useful for us to consider the use of AI within business practices, because more and more data is being generated. In fact, there are statistics that say that every 5 years, our data is multiplying 10 times. So it's really useful for human beings to use computers to analyze this massive data that is being generated in the real world. Additionally, another powerful thing or benefit of using artificial intelligence is that not only can it analyze massive data that human beings cannot do, it can also detect patterns within the data very effectively. So human beings cannot look at thousands and thousands of records and be able to detect patterns in seconds, but artificial intelligence can do. And therefore, you will see in subsequent slides when we talk about the ability to use artificial intelligence in business decision making. This detecting of patterns from massive data is one of the things that makes AI powerful within business practice. Now looking at the algorithms part of it, the fact that artificial intelligence can analyze data and then generate patterns or models that it can use to perform its tasks. One of the benefits here is that artificial intelligence can do so very quickly. So the rate at which artificial intelligence systems can perform their tasks based off the models they've developed is much faster than human beings. And so that makes artificial intelligence a very strong candidate for automating a lot of the business processes. And we'll talk about some of these processes in subsequent slides. Also, the fact that AI then does this very fast, it means that artificial intelligence, therefore, is great to automate processes. And so this is some of the benefits of artificial intelligence. It's fast processing and the fact that it can automate stuff so that human beings have more time on their hands to do other things. So if I can just stop here and give you a real life example, is Alexa, right? The fact that now you can ask Alexa to check the weather for you, it saves you time from sitting at a computer, opening the web browser and typing what is the weather. All you need to do is just ask Alexa while you're doing other stuff. So this is just the highlights I'm saying as the benefits of artificial intelligence and algorithms. However, there's nothing that is all good without some challenges, right? And so artificial intelligence too has its challenges. So the fact that it relies on a lot of data, there is this privacy concern, right? And so, for example, if you use Google Maps on your phone, Google Maps is actually collecting your data. And so there are privacy concerns. People are very concerned that the more data is being collected by these apps that we're using that have some artificial intelligence within them, the more our privacy is being not violated, but being compromised. And so there is need for us who use and develop AI to be aware of the data that this AI is using and whether there are sufficient safeguards for this data that belongs to human beings. Then I will not go into details, but there's also facts that our data that we use right now doesn't represent very well the population that it might be used in. And this is a more detailed challenge of artificial intelligence, the fact that artificial intelligence has some data bias within it. And I won't talk about this in detail right now, but later in more advanced classes, I'll go into the detail of data bias, what it is, and how this challenge can be overcome. Another challenge that artificial intelligence faces right now that is a very huge focus of research is that it is generally quite complex. So sometimes artificial intelligence systems do things that people cannot explain. So for example, there was recently there was a particular company, I won't mention its name, but there is a company that implemented an artificial intelligence system for recruitment purposes to hire new employees. And that artificial intelligence system tended to favor certain people than other types of people. And so it was very difficult to understand why that algorithm was doing so. And so that complexity of AI makes it very difficult to be able to correct whatever issues might be coming up as a result of its behavior or of its use. And so this is why AI faces this challenge that it is complex and it needs therefore to be made more transparent. And again, this is one challenge I'll just mention here that at a later stage I will talk about in more detail. Another thing is that many times we use artificial intelligence and we do not know it. It's invisible, right? So there was a video that was going on YouTube about some concerns in the UK of the fact that the government was using cameras to monitor people, right? It was able to use cameras in the streets to be able to recognize the faces of individuals and to be able to perform some sort of surveillance. So this invisibility of AI, the fact that there are technology that are right now perhaps monitoring you in the streets without your knowledge, that is another challenge of artificial intelligence, how to make humans more aware that they're interacting with artificial intelligence, and many times its implementation in the real world might not be very visible to the human because this is again technology that is embedded in different devices such as cameras. Again, this is very high level. I just want you to be aware that there are benefits and challenges of artificial intelligence, and in more advanced classes I'll go into this topic in more depth. So why do we need artificial intelligence? I've talked about the benefits and the challenges of AI. So why do we really need it if it has all these challenges that may perhaps overweigh the benefits? Well, I want to just highlight here that we as human beings, we have a lot of limitations as well. So we also are not perfect, and therefore AI is not perfect. And so the best model is for us to coexist and find a way to enhance or overcome the challenges that AI faces. So we as humans, we have certain limitations. For example, you can only read a limited amount of data at a particular time, and then you can only process a subset of that data that you've read, and then even a smaller subset is what you end up storing within your memory. So we have these information processing limitations within our minds. However, artificial intelligence, as I mentioned in the previous slide, has faster processing capabilities and is able to identify patterns better than human beings can do. And that is why in business, for example, in fraud detection, artificial intelligence is really being used to be able to detect anomalies. And I'll talk about this in later slides. So the main reason we need AI in accounting and auditing is to assist us overcome this information processing limitations. Because, for example, if you think about the role of an auditor, the auditor is supposed to understand the information of their audit clients, both the internal information, the private information within their client, and also all the public information that exists about their client. And so this is information overload. If you consider now that we have social media, we have all this information being generated at real time about individuals, about companies, about countries. It's so much information that is generated that is currently available in the public domain that auditors ought to be aware about as they continuously make their judgments, right? And so this need to understand all this massive information that's being generated in the real world. As I mentioned in the previous slide, the statistics is that we generate 10 times more data than we did in the previous 5 years. So more and more data is being generated. However, we still have the same minds. We still have those information processing limitations. And so we really do need to begin to rely more and more on artificial intelligence systems. And so I will be talking about in more advanced courses why that man plus machine model is the best, right? Where we don't rely wholly on machines because they do have their limitations, and we don't wholly rely on humans because, again, we know we do have limitations. And so we need to find a way to coexist. And I'll talk about this, as I said, in subsequent slides. So now that we've covered the second learning objective, which talked about the properties and the reasons why we are using artificial intelligence in accounting and auditing, I want to move on to the third learning objective. So in this particular objective, what I'll be trying to make clear to you is the different types of AI technologies. So there are several different types of artificial intelligence. What I'm going to try to do in this particular class is to cover on a very high level 8 different AI types. And as I cover each of these technologies, I'd like you just to understand the general mechanisms or uses of these technologies. And then in subsequent advanced classes, I'm going to dive deeper into these technologies and even provide hands-on exercises. But this is going to be just a general overview of these different types of AI techniques. And once I go through these techniques, I hope you'll be able, at the end of this particular learning objective, is that you'll be able to define what each of these techniques are and to be able to give at least one example of each of these techniques. So the first AI technique here I'm going to try to cover is chatbots. So chatbots are machines that can communicate with humans in natural language. So I'm sure you visited websites, and when you go onto those websites, there's a pop-up that comes, and that pop-up says, for example, hi, how can I help you? And so such pop-ups, generally, if you respond to them, you would get more text, right? And if you read those texts, sometimes it's very easy for you to determine if that text is from another human being or from a machine, because generally the machine responses might be very routine or very mechanic, right? So once you read that, if you get the illusion, right, when you're reading it, that you get this feeling that you're interacting with a human being, yet you're actually interacting with a machine, then we can say that particular machine is an AI, an artificial intelligence, a chatbot. And how you can get that feeling that you're interacting with a human being is because the AI would be able to respond seamlessly. It might respond using very informal language, right? So think about Alexa and Siri. These are very sophisticated AI chatbots that can be able to engage with you in natural language and make you feel as though sometimes you're talking to a human being. And you can see videos where children are actually engaging with Alexa and Siri and imagining that they're actually talking to a human being. So this is what chatbots are, and they're very useful, and I'll talk about their use cases in subsequent slides. So here I just want to again emphasize the difference between a chatbot and a live chat. So a chatbot again is you interacting, a human being interacting with a machine and getting that human-like experience. And remember in previous slides, I've talked about the Turing test, right? That test which one can use to determine whether a machine is truly artificial intelligence. And remember, we described the Turing test as that experience that gives a human being a human-like experience, although they're interacting with machines. So again, chatbots are machines that can engage with humans in natural language. However, live chats is you as a human being over technology, for example, over our website, interacting with another human being. So many times you can begin to chat with a chatbot, and the chatbot is unable to answer your questions. So what happens in the background is that chatbot will it will send a message to a human being on the other side, and will say, for example, there's a new customer who is asking about this product. Please respond. Then the human being will respond to the customer on behalf of the chatbot. So when the human being is invoked, right? So when the human being is involved in that process, then that becomes a live chat. It is no longer a chatbot. So chatbots are 100% automated with the machines responding to the human beings. So you might think that a chatbot was invented very recently, which is not the case. In fact, the first chatbot was invented, as you can see here, in 1966. So this chatbot, which was called Eliza, was able to answer psychological questions by the users, by the human beings who interacted with it. So here I just capture a snapshot of a recreated version of Eliza, and you can see Eliza is asking, is there something troubling you? And then a human being is responding in natural language. And you can see here the correspondence that's going on between Eliza, which is the chatbot, and the human being. And there was I read some article about this Eliza, and there were people who were expressing concern because in the 1960s, this was new. This was not perceived as possible. And so people began to feel like machines are possessing human-like characteristics, and it was pretty scary for them at that time. However, now we're becoming more comfortable with the use of Eliza, like tools, right? We're using now Alexa, we're using Siri in a very comfortable fashion, and it's becoming more and more ingrained in businesses. And I'll talk about this again in the next slides. So as I mentioned, chatbots, again, have several use cases in business. So in real life, we already are engaging with chatbots. There's Siri, there's Cortana, there's Alexa, there's Google Assistant. However, in accounting too, we're having chatbots being used. So there are new chatbots being developed that can assist clients file taxes. So think about the filing dates, right? When tax filings are due. This is the particular time when most people are trying to engage, trying to reach out to their accountants to be able to answer specific questions. And most of the time, they're very similar questions that people are asking. And so now accounting firms are developing chatbots to answer those accounting questions of their audit clients or of their regular individual clients. So that's when companies are using, specifically accounting firms, are using chatbots to enhance their business processes. And also audit firms are doing this as well to be able to support their audit clients. So having this chatbot facility is actually very useful and assisting them to be able to reduce the amount of human intervention to answer very simple questions. And this sort of frees up the time of their employees to do other useful things than responding to just routine, repetitive questions from customers. So I want to give you an audit example here, and I want to give you a real life example of EY. So EY is one of the big 4 audit firms, and EY have implemented a chatbot called EY Goldie. And if you go to their website, you'll be able to see that they are saying that within the first week of implementing that chatbot, and this chatbot could answer just questions that employees were having around regular human resource, activities, right? So how can I access my pay slip, those type of questions. So this was deployed first to just answer general human resource questions of employees, not to really support the audit work of employees. However, EY was mentioning that they want to actually move this chatbot to do more practice or professional activities. And so just within the first week of deploying this chatbot to answer human resource questions of their employees, that chatbot was able to answer 500,000 questions posed by employees. And within 28 days, that chatbot was able to save hours, man hours, equivalent to the amount of money that was invested to develop that chatbot. So in short, in 28 days, there was return on investment for that particular chatbot. So this is just to show you how much time is being freed up and is being saved by the use of chatbots. And this time being freed up, for example, in this particular case of EY Goldie, the human resource team's time was freed up to do other more intelligent tasks. And these routine questions were now being answered by the chatbot. And so this not only saved the time or the man hours, it also created a better work experience for the human resource team, because now they were able to be freed up to do more intelligent or more exciting things and not just repetitive stuff. So there's a lot of benefits to this sort of automation. So in finance, again, there are banks that are using these chatbots as well to help customers to do repetitive things like making money transfers, paying bills. And if you have any online banking experience, you'll know that there are always chatbots that are popping up to ask you, hey, can I help you? So this is just a way in which different companies are using chatbots to save money and enhance also customer experience. So there are many chatbot softwares out there that can help you develop a chatbot without any programming skills. IBM Watson is one of the most common or most spoken about AI that can do this. And IBM Watson gives you a very simple user interface, and it's enabling companies to very quickly develop chatbots to support their customers without having a strong IT department that has programming skills. And here I just list many other chatbot softwares, and these are not all of them, but these are just some of those chatbot softwares that you can very quickly engage in and be able to develop your own tools. So machine learning is a subset of artificial intelligence, which is concerned with extracting patterns or useful information from data, which can be used to perform both descriptive or predictive tasks. So I'm going to focus in the next few slides on what these descriptive or predictive tasks are that machine learning can do, using a particular example in finance. So one of the ways machine learning is being used is in performing predictive tasks. So an example of a predictive task within a business setting is determining whether a particular applicant for a loan will actually repay the loan, right? So banks are really using this, and other financial institutions are really using machine learning to assist them in performing this sort of automated predictive tasks. So I just want to spotlight here one of the apps right now called Quicken Loans, which online you can be able to apply for a loan within 8 minutes. You feed in your data and it can quickly be determined whether or not you will be a successful mortgage applicant or not. So this fast information processing is being done by algorithms such as machine learning, right? So the basic steps here would be, for example, if a new applicant goes online and fills in their customer data, the machine learning algorithm will examine the data attributes of this customer, this new applicant. And then based off the analysis of that data, the algorithm will try to determine whether or not those characteristics closely align with previous loan applicants who have successfully repaid their loans. And then based off that determination, the algorithm will decide whether or not to grant or reject the loan application. So this is just a high overview of what a predictive task looks like, and in a nutshell, how machine learning is able to perform these predictive tasks. Now, we're actually in advanced classes going to be able to perform machine learning using one of the off-the-shelf softwares. So a second type of task that machine learning can achieve is descriptive tasks. So an example of such a task would be describing the type of investor a particular investment firm is interacting with. So if, for example, an investment company has several investors, right? And these investors have different characteristics, right? So for example, we may say some are active investors, some are passive investors. And whenever this particular firm gets a new potential customer, it wants to very quickly determine whether this is potentially an active or a passive investor and know what products to market to that particular investor. So what firms use is machine learning to be able to analyze previous or current investors with that particular firm and understand what are the characteristics or features of those investors. For example, they might determine that active investors tend to have higher incomes than passive investors, or maybe active investors are younger than passive investors. So there could be so many different attributes that this particular machine learning algorithm might analyze in order for it to come to the conclusion that any new investor it encounters is either an active or a passive investor. So basically, this machine learning algorithm is able to analyze previous data, determine what the patterns are for active and passive investors, and then it's able to determine for any new potential investor what category they fall under, right? So this is a very simple illustration of the flow of descriptive tasks. So one of the real life examples of machine learning is recommender apps that are very common in applications such as Netflix or websites such as Amazon, right? So if you have been shopping on Amazon or you are currently watching movies on Netflix, you'll be familiar with the fact that once you begin to buy or watch certain movies, there is after maybe 2 or 3 movies, you begin to receive recommendations of movies that the app thinks you will like. So what the app generally does is, based off your previous views, perhaps after you've watched 2 or 3 movies, it will determine what type of viewer it thinks you are. Maybe you like action movies or you like horror movies. And so based off what you've been doing before, your past behavior, it will try to associate your past behavior to other previous viewers' behavior, right? And assign you to a particular group. For example, you will be assigned, if you like action movies, to the action movie group, right? So that is a descriptive task that the recommender app has performed. Then after that, once it knows who you are, it described you as an action movie watcher. The next thing is that it will try to predict what future movies it should be recommending for you. And you basically see when you open your Netflix app that those movies that you would tend to like generally are very easily accessible to you because they use this prediction mechanisms using machine learning. And so these prediction mechanisms basically just can predict what movies it thinks you would like. So this is just a real life example of machine learning in play. And many times, as I said in previous videos, artificial intelligence is invisible. So we are interacting with AI, yet we have no idea that we are doing this. So it has this invisible property, as I mentioned. So another example that I want to highlight here is a business example. So in budgeting and forecasting within business processes, this is an activity that financial managers historically used to perform. And basically, what this process is that a financial manager will look at all the financial statements of a particular year, look at the activities going on in the environment, in the country, and determine or project what profits they estimate would be made by a particular company. And they do this in collaboration with other managers in different departments. And so these projections usually are reported within the financial statements of companies. However, of late, there is more reliance on technology, for example, machine learning, to assist financial managers and other managers to project what their future profits may be. And so here, this is where they use predictive algorithms to analyze previous trends and then within the company, and also incorporate other external information within the macro environment, right? Within the country and even within globally, other companies within the same industry. So this is just very useful ways in which machine learning is enhancing business processes. Another use case of machine learning within accounting and auditing is in fraud detection. So machine learning is very effective in analyzing a huge bunch of data and detecting which ones are anomalies or which ones are not the normal transactions, which could be potentially fraudulent transactions. And one of these use cases, which I will talk about, which is actually from the financial industry, is the credit card companies, right? So whenever you do a transaction online, or when you go out of state and you do a transaction in a different state, usually the credit card might flag that transaction if it's very different from your previous transactions. That is, you're perhaps buying an item that's very different from the items you've normally been buying, or you're buying this item in a very different location from where you normally purchase your items. So once machine learning is used to analyze transactions like the credit card companies do, it can immediately detect that this is a very different transaction from the normal transactions, and it can flag that transaction as potentially anomalous. And that transaction, finally, you would get perhaps a text message that asks you, please confirm whether this transaction is legitimate or not. And all this has been done using the automated process. So another AI technique is smart analytics. So smart analytics is the ability for artificial intelligence to analyze a multitude of data generated by a company and harness it for insights that aid decision making. So smart analytics is a type of artificial intelligence that assists humans discover facts and relations that are difficult for the human mind to conceive. So usually smart analytics is used with big data, massive data, where there are thousands and thousands of transactions, and the human mind cannot be able to analyze this data. So I talked about machine learning in the previous slides. Machine learning is one of the elements of smart analytics, but smart analytics may have other components as well, such as business rules, right? So if you think about a company that operates Monday to Friday, and over the weekend it doesn't function, there could be business rules that say any transactions over the weekend are irregular. So such business rules, and there could be thousands of such business rules in companies, those could be incorporated to machine learning, right? By combining those business rules and machine learning and other statistical models, all this together, coming together, can achieve smart analytics. And there's an example of smart analytics, which is MindBridge software. And actually this screen that I am showing here is the way they describe how they achieve this MindBridge AI. And basically MindBridge AI is a software that auditors are using right now to be able to analyze thousands of transactions within the general ledger and to determine which transactions are of a high risk, and then they can focus more attention on those high risk transactions. So this is just a real life example of smart analytics. So just as a recap, we've gone through all these 8 different AI techniques. So chatbots are machines that can communicate with other humans in natural language. And we gave examples of Alexa and Siri. And then natural language processing is a branch of artificial intelligence that is concerned with enabling machines to process human language. And as we spoke before, chatbots exhibit these natural language processing capabilities. And then speech recognition is the ability for machines to interpret human voice. And then machine vision is the ability for machines to see, just like the self-driving cars. And we talked about in business, optical character readers. And then robotic process automation with an intelligence layer is the ability for robotic process automation, which is software, to automate business process flows. And here I give the example of robotic process automation, enabling accountants to perhaps download emails of invoices and extract information automatically from those invoices and automatically feed the information from the invoices into a financial system. So remember that that was one of the examples that I talked about in robotic process automation. And then Internet of Things is the ability for devices to communicate with each other without human intervention. And here I give the example of a warehouse and the robots navigating the warehouse and the ability of these robots to communicate directly with the financial system. And then I also talked about machine learning, which is really one of those core capabilities of artificial intelligence. And machine learning is this technology that enables AI to extract pattern and insights from data, which are useful for both descriptive and predictive tasks. And remember here, I gave the example of Netflix and Amazon recommender apps, which are very good at being able to learn customer trends and being able to recommend products to customers. And then smart analytics, lastly, is the ability to analyze multitude of data generated by companies for insight. So there are four main levels of intelligence. The first level of intelligence is mechanical intelligence. Mechanical intelligence basically enables AI to learn and adapt at the bare minimum. And remember, I talked about robotic process automation in the previous slides. And robotic process automation is that technique that enables AI to be able to extract information from an invoice, and then using optical character reading, be able to detect what the characters are within that invoice image, and then feed that data which it has extracted into the financial system. So this is very mechanical, right? This is just basically following instructions and using a little bit of intelligence. However, analytical intelligence is a level above mechanical intelligence. So this enables the AI to learn and adapt systematically based off data, right? So smart analytics that we talked about in the previous slide exhibits this analytical intelligence because it has the ability to analyze data systematically and perhaps do forecasting and budgeting, as I talked about in the previous slide. And then the third level of intelligence is intuitive intelligence. So intuitive intelligence enables AI to learn and adapt intuitively based off understanding. So this is a very sophisticated level of intelligence that not many artificial intelligence exhibit. So this intuitive level, I just want to share with you that this is really where we as humans excel and almost beat artificial intelligence art, because we are very good at being intuitive and guessing. You know, basically you could say, I have a feeling that something will happen, right? That's your intuition when you say, I have a feeling. So based off your previous experiences, you tend to form assumptions, right? For example, whenever you see clouds hanging over the sky, you have a feeling it's going to rain, right? It's your intuition. So this ability for you to learn and adapt intuitively is something that is very unique to human beings, and artificial intelligence is yet to really hit this intuitive intelligence very well. And then the last type of intelligence is empathetic intelligence. So basically, this is the ability to be empathetic or to feel or to understand or to bear with somebody else, right? So for example, in hospitality industry, this is where empathetic intelligence is really needed. When, for example, doctors and nurses are caring for sick patients, empathetic intelligence is really necessary to be able to interact well and understand what patients are going through as doctors in order for you to be a good doctor, right? And so if you're thinking about developing an AI that's a doctor, this would be a huge challenge because artificial intelligence is yet to reach that level where it can understand what other humans are going through. So basically, looking at this screen, I've talked you through the level of intelligence, and I'll let you know that, as you can see at the bottom side here of the slide, that as the time is going by, we are continuously trying to enhance this type of intelligence within AI. We are pretty good at mechanical and fairly well at analytical in terms of developing AI that can do this type of tasks. But for intuitive and empathetic intelligence at this particular moment, there isn't too many AIs that can operate in this space. And so I like to here just share with students that it's important for you now to know that you need to develop your professional skills beyond just analytical skills. You need to be able to sharpen your other critical thinking skills, because this will be those intuitive and empathetic skills that are really, really necessary for you to have when you want to excel in a profession where there's going to be a lot of artificial intelligence in use. And so now that we've completed this course, I hope you'll be able to achieve our learning objectives. And what you should be able to do now is you should be able to define artificial intelligence. You should be able to describe the properties, the benefits, and the challenges of AI. You should be able to describe the different types of AI technologies. And you should also be able to define the different levels of intelligence exhibited by AI. So another artificial intelligence technique that I will talk about is Internet of Things. So the Internet of Things is the interconnectivity of devices which enables them to communicate directly with each other. So a popular example of Internet of Things is the smart home, right? So people nowadays are trying to find ways to make devices within their homes communicate directly with each other. So for example, if you have a security system in your house, you want that perhaps connected to the lighting of your house so that when it's a specific time and you're not in the house, the security system can trigger all the lights in your house to perhaps go off inside, and then all the lights that are outside come on. So these are just ways in which devices can talk directly to each other within your home. So a business example of the Internet of Things is within warehouses of companies. So this is a very popular use case of Internet of Things, especially now when there's a lot more online purchasing, a lot of online orders. Companies are thinking about ways to automate the processing of online orders. And one way is the use of robots. So basically, you could have cases where humans can assist the robots or where the robots can act all on their own. And so if a new customer places an order online, right, that online order will go into the registry or into the financial system of the company. And this order can trigger a delivery request, right? So you can have robots going and collecting items from the shelf, placing those items from the shelf onto the cart, and can deliver those items to specific locations as requested. So here we're having more and more interventions of machines to be able to navigate and move within the warehouse based off instructions from another system over the Wi-Fi. So without any human intervention, clearly you can see here, the financial system can talk directly with the robot without any human intervention. And this indeed is Internet of Things. So there are several other use cases of Internet of Things other than warehouses. For example, in accounting and in auditing, right now, companies are beginning to use drones to perform inventory and asset inspections. So basically, traditionally in audit, the auditor is supposed to go and every year look at the existence and the state of assets, right, that are of a high value within a particular company. So instead of the auditor going and physically inspecting those assets, now there are piloting initiatives to have drones roving over the particular facility, and these drones being able to take pictures and analyze the images to determine whether assets exist and what the state of those assets are. So some of the Big Four firms are piloting the use of these drones to perform these inventory inspections to automate and save time for these particular audit procedures. So another AI technique is robotic process automation with an intelligence layer. So robotic process automation is a software, right? I know when you hear the word robot, you might think about the hardware, that machine, right? But when I talk about robotic process automation here, I'm talking about a software that automates the business process flows. So when I talk about business process flows, it's basically a series of activities that are done as part of the business function. So for example, if you think about an accountant, one of the things that they do is be able to process payments, right? So if a vendor sends an invoice for a particular good or service that he provided to the company, one of the things that an accountant would do is to process that invoice. So they would key in that invoice into the financial system of the company and then process it for payment. So if every day an accountant opens their email, downloads invoices from emails, and then extracts the information from the invoices and keys them into the financial system, these very clear steps, which are both manual and repetitive, can be automated using robotic process automation, right? So robotic process automation all on its own is not artificial intelligence. However, one needs to include an intelligent aspect to be able to make robotic process automation truly artificial intelligence. Using the same example that I just gave about keying in the invoices, if, for example, those invoices were scanned images, and we now need to use machine vision to extract those images or those letters or those numbers from the invoices and extract those images of the numbers and invoices and convert them into text, right, which can be keyed into the particular ERP, then that becomes robotic process automation with an intelligence layer, which is this optical character reading capability, this machine vision capability that we talked about in the previous videos. And now this makes this whole system artificial intelligence, the fact that it has this optical character reading or this intelligence layer. So in summary, robotic process automation automates manual and repetitive tasks. Basically, these are tasks that have very clear steps as to how to perform them, where there's no need for any human decisions or any judgment. Such tasks can be easily automated using robotic process automation. However, if there is need for judgment, then there is need for an intelligence layer. And when an intelligence layer is included, such like the optical character reader, then indeed this setup of RPA, robotic process automation with an intelligence layer, this then transforms the whole system into artificial intelligence. But without that intelligence layer, robotic process automation all on its own is not artificial intelligence. So the next AI technique I'm going to talk about is natural language processing. So natural language processing is a branch of artificial intelligence that is concerned with enabling machines to process human language. So think about yourself, right? You engaging with a chatbot and the chatbot being able to respond to what you're asking in your natural language. That basically is natural language processing. And so natural language processing is not limited to chatbots, which we've just spoken about. There are many other use cases of natural language processing. And so in the next few slides, I'm going to be talking about 3 main examples of natural language processing techniques. So the 3 main examples of natural language processing techniques that I'm going to talk about in this particular video is text clustering, text categorization, and sentiment analysis. So my purpose here is that you won't basically be able to do all these techniques or understand fully how these techniques work within different software. The main thing is that I just want you to understand what these techniques are, and then in subsequent advanced classes, we'll be able to do hands-on exercises with these specific techniques. So the first technique is text clustering. So text clustering is the automatic organization of text documents into groups. So when I talk about text documents, what I mean is, for example, tweets, right? Or social media posts or news articles. All of this can be text documents. Now, imagine you're a company and you want to determine what all your customers are saying about your products on Twitter. If you are producing millions and millions of products to millions and millions of customers, it would be very difficult for you to read all the tweets that are going on around your company's product. And so you can use automatic text clustering to be able to analyze all these textual documents online and be able to group these documents into unique clusters. So this is what text clustering is. And so you might wonder why we would even want to perform text clustering. So I just want to give you an example of text clustering that Deloitte have on their website. And so Deloitte have a very good discussion around the use of text clustering and other natural language processing techniques within the government. And so one example they give is that the Center for Tobacco Products here in the US, which is part of the Food and Drug Administration, uses text clustering. And basically what they do is, because they receive millions and millions of documents, they use text clustering to immediately group all those documents into specific clusters. And then they can review those clusters separately, right? Or they can do further processing separately for each of those clusters, instead of having a human being reading and sorting the documents. So this is very interesting. And they say this has enabled them to be able to very quickly draw insights from documents without having to read them in detail. A second example of natural language processing techniques is text categorization. Now, when I talked about text clustering in the previous slide, we did not know what groups were existing initially, right? So it's just a matter of clustering those documents based off their similarity. But in text categorization, the groupings are known, right? So I want to give you an example here of text categorization. This usually works with your email systems. Whenever you receive emails, your email software, if you're using Google Gmail, this software is able to immediately sort your emails into specific folders, right? For example, you have email that goes to your spam mail, or some that goes into promotions folder, or some that goes into your primary inbox. So this is just an example of an algorithm that does categorization. So when I talking about text categorization being used in companies, you'll see that several companies, for example, are receiving billions of emails daily, right? And so instead of them reading those emails, what they do is they use software to automatically analyze those emails and sort them or send them to specific departments for analysis, right? So for example, if you receive customer emails and you want them to immediately be sent to the returns department, the goods returns department, or the orders department, or the support department, or the complaints department, you can use this natural language processing technique to analyze these emails or these documents and sort them and send them out to their respective departments. So this is a very automated way of being able to sort, analyze, and categorize documents. And basically, sentiment analysis enables human beings to automatically analyze, using AI, the feelings or tones expressed in text, right? And so you can just here, I've just given you an image of different types of feedback that can be left by customers. And you can use natural language processing to analyze those reviews that have been left by the customer and determine, for example, if that review is positive, neutral, or negative. And this is very useful, again, as I mentioned, to just analyze massive amounts of textual information and draw some general insights from them. So we're going to perform sentiment and emotion analysis in more advanced classes. So there are several use cases of natural language processing. For example, chatbots are one of the real-life use cases of natural language processing, and we've talked about chatbots already. But then in accounting and auditing, there are more popular uses of natural language processing. For example, as I mentioned in the previous slides, assisting the audit client understand or analyze news or social media posts of their audit clients and be able to glean some insights from those analyses. We also have natural language processing being performed in fraud detection. For example, there is an artificial intelligence system that analyzes the descriptions in the general ledger of an audit client. And basically, the general ledger is a record of all the transactions within that particular audit client. And that particular AI is able to detect any descriptions for transactions that may contain potentially anomalous text, right? So, for example, anything about perhaps kickbacks or bribes. I'm just giving examples of words that could possibly be of high fraud risk. If any such words are mentioned or being discussed within the descriptions of transactions within the general ledger, those could be flagged by the algorithm. So this is another example of just use cases of natural language processing within accounting and auditing. So another AI technique is speech recognition. So speech recognition is the ability for machines to interpret the human voice. And so Alexa and Siri are very good examples of speech recognition, artificial intelligence. So when I mention speech recognition, there are several elements to speech recognition AI. So one element is the fact that speech recognition AI can detect the content of the speech. So for example, if you're interacting with Alexa, Alexa can be able to pick the content of whatever you're saying and can work on it. So for example, if you say, Alexa, what is the weather? Alexa can analyze the content of what you said. Another way in which speech recognition works is that it can perform speaker identification. So it can identify who has said what, right? So that is speaker identification. And one of the use cases here that I'll talk about for speaker identification is, for example, in the banking industry. There is, I believe, TD Bank that are talking about using voice to be able to interact with the customer and using voice to even identify the customer. So they claim that everybody has a unique voice print. And basically your voice print is composed of, for example, your accent, the speed at which you normally speak, the pitch of your speech, the common words that you use. So this is just speaker, all the different elements that identify a speaker, right? So speaker identification is something else that can be done, and it's very useful in being able to, as I said before, validate a human being using their voice print. Then another speech recognition technique is the ability to analyze language, right? Language interpretation. And so we have software nowadays that can be able to listen to you as you speak and can determine what language you're speaking in and can actually interpret your language into another language, right? So that is language interpretation, and that is also another capability of speech recognition software. And then another capability is, again, that speech recognition can be able to detect the tone in which somebody is speaking. So for example, if you are using a chatbot, and remember in the beginning, I talked about chatbots being automated and then live chats being a human being who is behind the live chat. If an artificial intelligence system is being used for customer support and it's able to analyze the tone of the customer, it can determine if a customer is happy. And if the customer is happy, it can decide, okay, the customer is patient enough to engage with a chatbot. But if it realizes that the tone of the customer is agitated, they sound more angry, the AI can divert the particular customer to a live chat to engage with a human being. So this is an example of tone analysis that can be done by artificial intelligence. So these are just different capabilities of speech recognition software. So as I mentioned before, speech recognition, therefore, is not just a one-off thing. In fact, it is a compilation of different capabilities to enable speech recognition software to work. So there are several examples of speech recognition software. Real-life examples include like Google Voice, Cortana, Alexa, Siri. But then in the accounting field, we are seeing very interesting use cases of artificial intelligence speech recognition software coming up. So for example, one interesting way is that nowadays, instead of sitting down on a computer and typing in accounting entries, people can actually dictate accounting entries into a financial system. They don't have to sit down and key. So wherever you are, so long as you have your phone and your phone has the app, an app that has dictation, you can be able to dictate your accounting entries without having to sit on the computer and type them. This is very interesting and time saving. So there are so many other use cases of speech recognition, and with time, as we progress into advanced courses, we'll be able to look into each one of these. Another AI technique I want to highlight here is machine vision. So we've talked a little bit about self-driving cars in the beginning of this class, and self-driving cars are an example of machine vision because they have ability to see, right? Just like human beings, they have this ability to analyze the environment and interpret the signals that are coming from the environment. So in order to develop machine vision software, one has to train the artificial intelligence. And how you train an artificial intelligence is just like the way we train children, right? So children usually at a young age receive books, and in the books there are pictures of trees, apples, bananas, and those images are labeled, right? So for example, the child will look at an image of a tree, and then they will read the word tree, and with time they'll be able to learn that that image is associated with trees. And even though they might encounter other trees that don't look like that first tree they saw, with time, after seeing several trees, they will learn what the characteristics of trees are. And so no matter what tree they see, they will be able to know that most trees have trunks, they have branches, they have leaves. And so those rules will be embedded in the mind of the child. Similarly, for us, as we grow up, we continue to develop our knowledge base of what images are and what their labels are. And with time, we are very good at looking at new things that we've never seen before and guessing what those things are. And so if we look at this image here, this is an interesting image that I got from the Free Code Camp. And this is actually an image that is a challenge, because it's a challenge to developers of software for them to develop an artificial intelligence that can look at these different images and be able to detect whether the image is a muffin or a chihuahua. And so how this can be done is by getting thousands of muffin images, different muffin images, and training the artificial intelligence on what a muffin looks like, right? So this is basically just uploading into the artificial intelligence labeled muffin pictures. And then the artificial intelligence will begin to analyze those images and determine what are the different features of a muffin, right? And then you'll do the same for chihuahuas. And with time, the AI will begin to know that chihuahuas have symmetrical, perhaps, eyes. There's an equal distance or a triangular distance between the eyes and the nose. There will be so many different things that are rules that the AI could end up developing that can assist it to determine the difference between chihuahuas and muffins. So you don't need to give the AI rules. Instead, you just need to expose a lot of data to the artificial intelligence, and the AI will be able to, with time, learn what different objects look like. So this is very popular. I talked about self-driving cars in the beginning of this video. Self-driving cars are that example of artificial intelligence that is trained on billions of images For example, you can upload labeled images of aeroplanes, birds, cars, people, trucks, and those images will be labeled into that artificial intelligence. And with time, it will learn what each image represents and can be able to predict when it sees new objects in the environment, what those objects really are. So this is a very high level of machine vision. So my previous examples of machine vision have been mostly around self-driving cars. However, I want to talk about a business example. And this business example is optical character reading. So optical character reading is the ability for an AI to analyze documents, scanned documents, right? And be able to detect characters or words within those documents. So basically, previously it's been very challenging for auditors or accountants to be able to analyze scanned documents. Documents that have been typed in are easy to highlight, copy, and paste. But as you know, scanned documents are very difficult to extract data from. So this optical character recognition software is able to extract letters from scanned images or pictures. So this is one of the common uses of machine vision within businesses. And so, as I mentioned here, that there is optical character readers. A good machine vision use case here is a software that has been released that can be able to scan invoices and extract the data within those invoices and feed them directly into an accounting system. So this software is interesting because it saves a lot of time. Previously, accountants had to key in each of the data that is within the invoice into the financial system. However, by using optical character reading, they're able to just scan the data which is within the invoices directly into the accounting systems. So this machine vision capability indeed is able to save a lot of time for accountants and